Okay, let's get started with the Unit 2 test review. As always, Obi-Wan Kenobi. Alright, so we got to keep in mind there's going to be multiple ways to do some of these problems, so sometimes I'll show a couple ways, sometimes I'm just going to show what I consider to be the most straightforward way. If we take a look at number 1 here, this is one of those problems where there are two different ways to approach it, and I'd like to show each way. So method number 1 is to treat this like it's a regular equation. This equation right here is really no different than something like this, where I have 2t minus 3 equals 11. What I have is a variable. I have a coefficient in front of the variable, coefficient in front of the variable, subtracting a constant, equal to a constant, equal to a constant. All right, so these are essentially the exact same types of problems. The only difference is, in this particular problem right here, I have fractions for all these numbers, whereas this problem here has integers for those numbers. It doesn't make the problem any more difficult or different to do. It's just that when we move in numbers, we're dealing with fraction numbers instead of integer numbers. So let's go ahead and get rid of all these markings here. All right, so to solve this problem, we would have to get rid of this constant, so I would simply add 3/5 to both sides. Those are inverses, so they're going to cancel out, leaving us with 1/10 t equals, now on the other side, I do have to figure out what 9/20 plus 3/5 is, but that's what your guys' calculators are for. If you're not comfortable with fractions and doing it by hand, you have calculators to do that, and you will find out that that comes out to be 21/20. My next step is to get rid of this 1/10 out in front of the t. I could either divide by 1/10, or I could multiply by the reciprocal. Do the same thing on this side. Here, those are inverses, they cancel each other out. I'm left with my variable t, and over here 21/20 times 10/1 becomes just 21/2, or 10.5. Okay, so that's one scenario. The other scenario I could approach to solving this problem is to get rid of the fractions as an extra step. All right, now I want to point out this took 2 steps. Step 1 was adding 3/5 to both sides. Step 2 was multiplying both sides by 10/1. If I choose to get rid of the fractions, it's going to add an extra step, and that's just a step of getting rid of fractions. To do that, we want to look at all the denominators here. So we've got a 10, a 5, and a 20. And for those 3 denominators, they have a common denominator of 20. So if I take this problem, I'm going to just rewrite it here. 1/10 t minus 3/5 equals 9/20. I'm going to multiply each of these terms times 20. Now in this first one here, the 20 and the 10 will cancel out, leaving me with 2, and I get 2t. Here, the 20 and the 5 cancel out, leaving me with a 4, so 4 times 3, I get minus 12. Here, the 20 and the 20 cancel out completely, leaving me with just 9. So that's step 1, we got rid of the fractions. Step 2, we add 12 to both sides, and we get 2t equals 21. Step 3, divide by 2, t equals 21/2, or 10.5. Again, exact same answer that we got right here, okay? 21/2, 10.5. 20/2, 10.5. This was 2 steps. This was 1, 2, 3 steps. Your preference. All right, let's take a look at number 2 here. Number 2, we just have basic equation, but we have some distributive property. And so right here we have to do a little distributive property. Here we're also going to have to use distributive property because we have this negative out in front of the parentheses. Okay? So we're going to distribute the 4 to the 3t, which gives us 12t. Distribute 4 to the 2, which gives us plus 8. This minus sign right here is like having a negative 1 in front. So we're going to distribute negative 1 times 3 is going to give us minus 3, or negative 3. Negative 1 times a minus t, the two negatives will cancel out and we get plus t. Now this side, we didn't do anything with it. So now, on the right-hand side of my equation, I have 12t and t, which are like terms, plus 8 and minus 3 are also like terms. So we're going to combine those like terms together. These two combine to make 13t. These two right here combine to make positive 5, or plus 5. Again, haven't done anything on the left-hand side. Now that everything's simplified, I can focus on my variable t. All right, at this point, when we started the problem, I had t here and t here, and I can't focus in two places simultaneously. We started simplifying using distributive property, but I still have t's here and here, so again, can't focus because there's too many t's. Now, that is the only t in the problem. So that means we could focus on that, and to solve for that t and get it by itself, we have to first get rid of this 5, and it leaves us with 13 on the left side equal to 13t. And then we get rid of the 13 using division, and we get t equal to 1. And that's our answer. Number 3 here, similar to number 2, it's just that we have a bunch of distributive property in like terms, and we could see that we have variables on the left-hand side of the equation and on the right-hand side of the equation. So we're going to have to do some simplifying and some rearranging. All right, so let's kind of separate our two sides. On the left-hand side here, I'm going to distribute that negative 2, which gives me negative 2t, distribute it to the minus 5, which is going to give me positive 10. Now, I didn't do anything with this 18 right here, so that just comes down untouched. On the right side, we're going to do 3 times 3t, and that gives us 9t. Distribute 3 times 2, that gives us plus 6. Here we have, again, negative 1, so we distribute negative 1 times 3 gives us negative 3. Negative 1 times 11t gives us minus 11t. On the left side, 18 and 10 are like terms, so they make 28 minus 2t. On the right side, 9t and 11t are like terms. Putting those together, we get negative 2t. 6 and negative 3 are like terms. Putting those together, we get plus 3. Now, I still have variables on both sides of my equation. I have a t there, and I have a t there. I can't focus in two spots, so we're going to get rid of one of those. We're going to add 2t to the left side. And whatever we do there, we have to do the same thing over here. These are opposites, so they cancel out, and I'm left with 28. Well, on the right side, they're still opposites, so they still cancel out, and I'm left with positive 3. So I have an equation here that says 28 equals 3. There's not even a variable left. So, side note, when the variable disappears, if the statement is false, then we have no solution. Okay? If it was a true statement, then we would say infinitely many solutions or all real solutions. Okay? So since this one is a false statement, 28 does not equal 3, we say that there is no solution. Okay, let's take a look at number 4. Number 4 is an absolute value equation. Okay, and in absolute value equations, just like the other equations, we're trying to get the variable by itself, but getting rid of the absolute value bars is its own step. So we're going to have to do a separate step to get rid of absolute value bars. So we start peeling away things from the outside first. So outside the absolute value bars, we have a 2 in front and a 3 at the end. So those have to be taken away first. So we get rid of the 3 from both sides, and we're left with 2 times the absolute value of 3x plus 2, and then on the right side we're left with a 12. So again, we're getting rid of the outside stuff, so we divide it by 2 on each side, and we get the absolute value of 3x plus 2 equals 6. Now this is an important point of the problem, because what we have here is an absolute value bar all by itself. Doesn't matter what's inside of it. There's nothing outside the absolute value bar. And on the other side, we have this number. So looking and seeing absolute value of something equal to this over here, this is the point where we are making a statement about our distance. What we are stating right here is that our distance from 0 is 6. So if we picture a number line, there's 0. If I were to take 6 steps, I could go 6 steps to the right, which would put me at positive 6. I could go 6 steps to the left, which would put me at negative 6. That means whatever is inside these absolute value bars, that is a distance of 6. So in other words, 6 steps away from 0. This stuff here is either going to be sitting on negative 6 or on positive 6, which means 3x plus 2 equals negative 6, or 3x plus 2 equals positive 6. And that's the step that we do to get rid of the absolute value bars. And yes, we have to do that step, and yes, we have to do it at the right time of the problem. And the right time to do that step is when there is nothing outside the absolute value bars. So up here, we had a 3 outside the absolute value bars. We had a 2 outside the absolute value bars. That is not the right time to split our problem. After we got rid of the 3 and got rid of the 2, this is the right time to split our problem, because now we could say, I understand what this statement is. I have the distance of something equal to 6, which means we're at negative 6 or positive 6. So now if we just continue these problems, we're going to subtract 2 off of each side. And that gives us 3x equal to negative 8. Divide by 3 on each side, and we get x equals negative 8/3, which if I type into a calculator is about negative 2.67. Okay, the reason we say about is because on your calculator you should see it goes negative 2.66666666, and at the very end you'll see a 7. And that's because it's a repeating decimal, it doesn't stop, so we just have to round it off. When we solve this side here, subtract 2 off of each side, we get 3x equals 4, divide by 3, and we get x equals 4/3, which is about 1.33. And I say that because, again, it doesn't stop at 2 3s. It keeps going indefinitely because it's a repeating decimal. So we get 2 answers here. We get x equal to negative 8/3, or negative 2.67, or x equal to 4/3, 1.33. If we take a look at number 5. Number 5 is an absolute value problem again. This time, though, at the very start, here's my absolute value bars. I have nothing outside my absolute value bars. Okay? So I don't have to worry about getting rid of anything on the outside of the absolute value bars. I can go straight to the fact that in my head, I have something that has a distance is 3t plus 4 steps from 0. So if I picture a number line, here's 0. I can move to the right, which would be like adding 3t plus 4, and that gives me 3t plus 4. If I move to the left, that would be like subtracting 3t plus 4, which would put me at negative 3t minus 4. So that means whatever's inside these absolute value bars, which in this case is 2t plus 5, this thing is going to be sitting on the number line either right here at negative 3t minus 4 or right here at 3t plus 4. So we have to, again, explore both scenarios. So we could say that 2t plus 5 equals negative 3t minus 4, or 2t plus 5 equals 3t plus 4. If we solve this one, I'm going to add 3t to get my variables on the same side. Now I have 5t plus 5 equals negative 4. I'm going to subtract 5 off of each side. 5t equals negative 9. Divide by 5. T equals negative 1.8. If I solve this side here, I'm going to subtract 2t from each side, and that gives me 5 equal to t plus 4. I'm just going to subtract 4 off of each side, and I get 1 equal to t. Now right now at this point I have 2 possible answers. I do need to check, and the reason I need to check here and the reason I didn't have to check here is because in this problem, at this point, remember we said that's a crucial point in the problem because we have the absolute value bars alone equal to something. This is the point where we figure out what our distance has to equal. So in this problem, our distance was equal to 6. There is absolutely nothing wrong with saying our distance is 6. Okay, we understand what it means to take 6 steps. What we don't understand and what we can't have is a negative distance. Okay, we cannot have a negative distance because we don't know what that means. What does it mean to go in negative distance? We could go in negative direction. That means just going to the left. That's negative direction, but a negative distance doesn't exist. So when we look at this problem right here, when we were at that crucial point in the problem and we had the absolute value all by itself and we looked at what our distance was, our distance has a variable in it, which means we don't know what our distance is, which means our distance could theoretically be negative depending on what I put in for t, and we're not allowed to have a negative distance. So what I need to do now is verify the 2 answers that I got, negative 1.8 and 1, I have to see if they actually work in that problem. So if I put negative 1.8 in there, we have the absolute value of 2 times negative 1.8 plus 5, absolute value bar, equals 3 times negative 1.8 plus 4. So this is the absolute value. 2 times negative 1.8 right there is negative 3.6 plus 5. 3 times negative 1.8 is negative 5.4 plus 4. Negative 3.6 plus 5 becomes positive 1.4. Negative 5.4 plus 4 is negative 1.4. And then finally, the absolute value of 1.4 is 1.4. And the right side is negative 1.4. These 2 sides are not equal. And because they are not equal, this answer right here gets thrown out because it is what's called an extraneous solution. An extraneous solution is not an answer. It's correct work that we figured out and we did correctly. It's just that it's not an answer that's going to work in our actual problem, so we have to throw it away. If we check the t equal to 1 answer that we got, we'd have the absolute value of 2 times 1 plus 5 equals 3 times 1 plus 4. This gives us the absolute value of 2 plus 5. This gives us 3 plus 4. This gives us the absolute value of 7. 3 plus 4 is 7. And the absolute value of 7 is 7. And the right side is already 7. that works out. That means this is our answer or our solution. Okay,